what we need to know in Unit 1 is how to write something or an expression with a radical and how to write it as a rational exponent. These are two different methods for writing an expression that would be equivalent to each other. So let's say that I wanted to take x to the 5/3. This is a rational exponent. We just talked about that a rational number can be written as a fraction. 5/3 is a fraction. So I've got x raised to a rational exponent. Using the definition of a rational exponent, we can rewrite this as a root or as a radical. The number that's on the bottom of your rational exponent or in its denominator would represent the root of my equivalent expression. So I could say x to the 5/3 is the same as the cube root of x to the 5th. I've still got my exponent of 5 represented and my exponent of 3 represented, but they're in different locations now, but these expressions are equivalent. So by that same concept, I can rewrite a to the 7/4 as the fourth root of a to the 7th. C to the 2/9 I could rewrite as the 9th root of c to the 2nd. And if you'll recall for me, this root tells you how many groups you'd be looking for within the prime factorization of the radicand, what is under the radical. So this is telling me to look for groups of 3 in x to the 5th. If I think about, so this can be simplified a little bit further. If I think about x to the 5th, that's 5 x's. So x to the 5th is the same thing as x times x times x times x times x, 5 times. The cube root tells me to look for groups of 3, so there is one group of 3 x's. So I am able to pull out 1x in front of my cube root. What's left underneath are those 2 x's that were not a member of a group of 3. So we'll write it as x times the cube root of x to the 2nd. But before I could do the simplification, I had to recall what that rational exponent was as a root. So it's important I remember how to rewrite that. This guy can also be simplified once I rewrite him as a root. If I thought about my groups of 7 A's, you have a group of 4 one time, so I can pull out an A in the front. And then I have 3 A's that are not a part of a group of 4. So I'll leave a to the 3rd underneath and still have my index of 4. If I look at this last one, I'm looking for groups of 9 within c to the 2nd. Well, c to the 2nd is c times c. There's no groups of 9 there. So that one is already simplified. Let's rewrite these guys as a rational exponent. There's no index listed here. That's called a square root. There's an understood index of 2. So this is the same thing as saying 6. And what power is 6 raised to? It has an invisible power of 1. So this is the same thing as saying 6 to the 1/2. That's the same thing as the square root of 2. This guy would be the same thing as 10 to the 1/3. 10 has an invisible power of 1. And the root is 3. The fourth root of 5 to the 2nd is the same thing as 5 to the 2/4 power. But I wouldn't want to leave a power 2/4. I know that that is equal to 1/2. So let's rewrite that guy as 5 to the 1/2. And that is the definition of a rational exponent. Hope you remembered.